Hello, we are talking about Pascal's triangle today. Who is Pascal? He was a French mathematician. His name was Blaise Pascal. He lived from 1623 to 1662. It looks like he was only 39 years old when he died. We're looking at these triangles, and there's some cool stuff about Pascal's triangle, so that's why I'm showing it to you today. And everything has to do with our combination formula that we talked about in the previous lessons. And I just want to give an example, like where some of these numbers come from. And let's look at C for 2. And this is row 0, 1, 2, 3, 4, and this is row 0, 1, 2, 3, 4. And so we're looking at row 4, and I want you to look at these as each of these numbers on this side correspond to numbers on that side. Okay, so we're going to use one case for example where we have the combination formula C for 2, where 4 is my n, that's the number of distinct objects, and r is the number of objects taken from those distinct objects. That's what my r stands for. So let's just go ahead and figure out what is C for 2. And C for 2 is, well, if this is my n, that's going to be 4 factorial divided by 4 minus, well, what's my r? My r is 2 factorial times 2 factorial, because that's my r. And 4 factorial means 4 times 3 times 2 times 1, which is 24. And 4 minus 2 is 2 factorial. 2 factorial is 2 times 1 is 2. And we have another 2 factorial. 2 times 1 is 2. And we get 24 divided by 4, which is equal to 6. And something really cool happens. We can see that this value here, this C42, corresponds to this value in row 4. But who wants to go ahead and use that formula constantly? That's a lot of work. So let's just create a cheat, okay? And our cheat today is, remember, row 0 is always a 1. Row 1 is always 1, 1. The first digit and the last digit on every single row, I don't care if you go up to row 153, will always be 1s. So how can you get these middle numbers without using this crazy formula? And I'm going to show you. So where does this 2 come from? Well, let's just look. I'm going to use a different color here. This 2, I'm going to look at the row above this 2, the 2 numbers that are closest to this 2. And it looks like a 1 and a 1 are closest to this 2 right here. And guess what? 1 plus 1 is 2. We're just using simple addition. Let's try row 3. And we're going to see, hey, where did this 3 come from? I'm going to look at the row right above, row 2, and the numbers that are closest to this 3 are this 1 here and this 2 here. And what's 1 plus 2? 3. How about this 3 here? What are the numbers that are closest to it? Well, this 2 and this 1. Add them up, 3. How about on row 4? Where did these numbers come from? And we can look at this and we can say, well, this 4, the numbers closest to this 4 are this 1 and this 3. We get 4. This 6 has this 3 closest to it and this 3. 3 plus 3 is 6. This 4 has this 3 and this 1 closest to it. 3 plus 1 is 4. And remember, the last digit in every single row will be a 1. And we are going to try to determine what is the value of each place in row 5. And that would be C5, 0, C5, 1. I think you see where I'm going with this, all the way up to 5. Okay, so what are the corresponding values? Well, for C50, that's 1. And now I'm looking at the second digit. Hey, guess what? I'm just going to add this number and this number. What's 1 plus 4? 5. What's 4 plus 6? 10. What's 6 plus 4? 10. What's 4 plus 1? 5. And what does the row end with? A 1. So those are the values for row 5. Can you see what the values would be for row 6? Have a good day. It was nice seeing you.